imagine that we've got some expressions that have got fractions in them. Now, we've said all along, algebra is just doing arithmetic when we don't know the numbers. So we better make sure before we get into algebraic fractions, or fractions involving algebra, that we can actually do it with straight numbers. So let's recap how the hell we add up and add, multiply, subtract and divide fractions. And I've tried to summarise it in one spot. I said to add or subtract fractions you need a common denominator. He really wants to get out, that bloke. Anyway, someone should let him out. Okay, to multiply fractions, multiply the numerators and multiply the denominators. I should have put that one first. But anyway, and to divide fractions, you multiply the numerator and the denominator by the reciprocal of the denominator. That sounds really fancy. You probably remember it as invert and multiply. That's saying the same thing. But anyway, let me just highlight that and say that's how we work with fractions when we're just using numbers. So for example, let me do the multiplication one first. So in here I'll do C first. So it says 2 times 5 times 1/3. It says multiply the numerators, multiply the denominators. So that's the same as 2 times 1 divided by 5 times 3. And so you get there 2/15. That's how we work with fractions when we've got numbers, right? Multiply the numerators, multiply the denominators. Now we can go back and do an addition. Because it says with addition, rewrite them with a common denominator. So here I can write this. If I do this 2/5 plus 1/3, I can write 2/5 equivalently as 2/5 times 3 on 3. 3 on 3 being just 1. So anything times 1 is itself. And then I'm going to add 1/3, and I'm going to multiply that by 1 as well, except I'm going to call 1 5 divided by 5. And you can see here I've chosen this denominator in the first one, and for the second one I've chosen that denominator. The reason being is that this comes out to be 2 times 3 on 5 times 3, so that is 6/15, plus 5 times 1 is 5 on 15. So I now have the same denominator in here. So by choosing the 3 there and a 5 there, I've turned them both into 15. And the idea being if I've got 6/15 and 5/15, I can add them up, I've got 11/15. And so now my answer is 11 on 15. So by putting them over a common denominator, I can then just add them up. To work out what certainly a common denominator, it doesn't have to be this one, but multiplying those two numbers together will give me my common denominator. Okay? That's how we work with numbers. Better do a subtraction as well. So in here, this one will be, again, my common denominator will be 15ths. So I'll write that as 2/5 times 3 on 3 minus 1/3 times 5 on 5, which gives me 6/15 minus 5/15. And so I'll end up with 1 on 15 with a subtraction. We've done C. Come down and do D now. And in here D, we have 2/5 divided by 1/3. And the way you're usually, I've heard it done anyway in schools, would be, so this is 2/5, and then you multiply by the invert and multiply, I think is what you say. Essentially, if I can scribble somewhere, let me scribble on the back of this. Essentially what we've done here is this, if I can go. I've got 2/5 divided by 1/3. And what I've said is that's the same as 2/5 times 3 on 1 over 1/3 times 3 on 1. So what I've done there is I've multiplied the numerator and the denominator by the reciprocal of the denominator. All right, that's what I've done. There's the reciprocal, and I've multiplied the numerator and the denominator. Now, 1/3 times 3 on 1 is just 1, and so this is the same as 2/5 times 3 on 1. So that's my invert and multiply. But there's why I do it. Sitting there. Let me just leave that one there. And so once you've got that in your head, you just very simply say, okay, I'm going to invert and multiply. Now to multiply, I multiply the numerators, which is 2 times 3, multiply the denominators, which is 5 times 1, and I end up with 6/5. So there we are. That's how we handle fractions with numbers. So we're going to do exactly the same with algebra. Whatever we did here, that's what we have to do in our algebra as well. So let's see if we can do it. Simplify these algebraic expressions. I'll leave these here to remind us what to do. So part A says we are adding fractions, so I'm going to put them over a common denominator, and you can see my denominators here are 2 and 3, so a likely common denominator that I'm going to use is 2 times 3 is 6. So in here, I want these to both have a denominator of 6. So I'm going to say A on 2, and I'm going to multiply by 3 on 3. I'm going to multiply by 1. Plus A on 3, and I'm going to multiply by 1 again, except this time it's going to be 2 on 2. So here, multiply the numerators. That's 3A over 6 plus 2A over 6. I now have common denominator, so I can just add up the numerators, and I get 2A plus 3A over 6, and I can collect those as like terms and end up with 5A on 6. Now in there, I wrote all of those steps in. I suspect that once you're off your L plates, or if you understand what's going on, you probably can go straight from there to there without writing the intermediate steps. But if you need to think about it, then I suggest write the steps down. Helps you not make mistakes if you write down the intermediate steps. Okay, let's do B. B says x on 5 minus y on 10. Now, I'll do this two ways. When you first look at it, you might say, oh look, common denominator is going to be 50, 5 times 10. We could do that. So in which case that would be x on 5 times 10 on 10 minus y on 10 times 5 on 5. So that gives me 10x on 50 minus 5y on 50. And so that would end up being 10x minus 5y, which I can't simplify, all on 50. And there would be that algebraic expression rearranged. Is that simpler than that? I don't know. But they're certainly equal. They're the same number. But of course, I could have done it this way. I could have said in here that 5 and 10 have a common factor of 10, or a common multiple, if you like, of 10. So I could have said, look, this is x on 5 times 2 on 2 minus y on 10. So that's 2x on 10 minus y on 10. and that gives me 2x minus y on 10. So that expression is the same as that expression is the same as that expression. They all represent the same number. Now, a little bit down the track, I think on Thursday we start talking about factorisations and so forth, and you can see up here I've got a common factor of 5, I can cancel things out. Okay, so I can rearrange that to that. But look, I don't care which way you do it out of these, they're all correct. Okay? They all are valid rearrangements and they all represent the same number. We would say, I guess, these are equivalent fractions, just like we said over here. 6/15 is the same fraction as 2/5. They're equivalent fractions, is all. That's all we're doing. Okay, C, we can do C. It says A on 2 times 4B on 5. Multiply the numerators, multiply the denominators. And again, once again, if you wanted to, you could write that as 2AB on 5. But we'll come to that in a minute. And lastly, our division. D. I have A divided by 2 divided by 4B on 5. I know that if I multiply the numerator and the denominator by the reciprocal of the denominator, I end up with that being 5 on 4B. Then I multiply the denominators, excuse me, and multiply the denominators, and I get 5A on 8B. That expression and that expression represent the same number. Okay, so we have a fair few tricks in our book. Here we can handle algebraic fractions. All we need now is practice. Okay? Theoretically we know what to do. Let's see how we go in actually doing it. So it says simplify the algebraic expression. So here we go. Part A says A plus 2 on 3. Now I would actually like to write that like this. A minus 1 on 4. So that I can tell which number is which and what operation goes with what operation. So I find the brackets in there make it a little bit clearer. That's up to you whether you need to do that or not. Now I have here some fractions. I need to subtract them. So the idea being I would want a common denominator. The obvious common denominator in this case would be 12, 3 times 4. So I'm going to write this as A plus 2 on 3 times 4 on 4 minus A minus 1 on 4 times 3 on 3. When I'm multiplying fractions here, I multiply the numerators. So this becomes 4 lots of A plus 2 on 12 minus 3 lots of A minus 1 on 12. These have a common denominator, so now I can just combine them. I'll come over here. So this is 4A plus 2 minus 3A minus 1, all on 12. That's good. That's a nice rearrangement. I can probably simplify that some further, a bit further if I want to, because I can multiply or expand out the grouping symbols here. I use my distributive law. And so this will become 4A plus 8 minus 3A. Now look at this as minus 3 times minus 1. So that's plus 3 sitting there, all on 12. Now I'm going to collect my like terms. So here I've expanded the brackets. Here I'm going to collect like terms. I've got 4a minus 3a is a. 8 plus 3 is 11 on 12. That I can't simplify any further. And so I'd say that's as far as I can go. So that algebraic expression and that algebraic expression are the same. Yeah? Minus 3 times minus 1 is sitting there. Thank you. The thing is, if I wasn't certain what to do there, I could just put a little number here. Just say I put a equal to 2. Oh, 2's not going to work very well. If I put a equal to 1, see I get 12 on 12. That whole thing ends up being 1, doesn't it? If I put a equal to 1 up here, I've got 3. 3 on 3, that's 1. That's 0. I also get 1 up there. So it would tend to suggest that I've done the right thing sitting there, just by checking with some numbers, in fact. Okay, that was A. Now, as I say, as you get better, you will not need to write down as many of the steps, but I would urge you to write down as many steps as you need to do to keep things in your head properly, because there's plenty of room for making little arithmetic slip-ups in there. Okay, let's do some of the others. I'll get some paper here. Let's do B now. So B says here, I have 2x plus 12y on 24x. Now that looks pretty simple already, but in this case we're going to go backwards, in fact, because I can do this. In here I can write this as 2 times x plus 6y. Have a look at that. Let's go back the other way. If I use my distributive law, 2 times x is 2x, 2 times 6y is 12y. So that expression and that expression are the same thing. So what I've done is I've said, look, I can see that this number has 2 as a factor, this number also has 2 as a factor, so therefore I can take it out the front. So I've used my distributive law in reverse, if you like. Now down the bottom, I can say that's 2 times 12x. 24x is the same as 2 times 12. And so this now becomes 2 on 2 times x plus 6y on 12x. Again, we know when I multiply two fractions, I multiply the numerators, multiply the denominators. So I've just done the reverse step there. And of course 2 divided by 2 is 1. Anything multiplied by 1 is itself. And so here I have x plus 6y on 12x. So this expression can be rewritten as that. So effectively what we've done is we've cancelled out the 2, is the terminology that's used there. But you can see essentially all I'm doing is I'm multiplying by 2 and I'm dividing by 2. That's the same as multiplying by 1. So in here we say I have cancelled the 2's and going from there to there. So that's another way in which we can simplify our algebraic fractions, by cancelling out common factors. We're going to do some more factorisation next time, but that's our start. So here's another one where we can do the same sort of thing here in C. C is 5ab plus 15bc plus 5b. all over 25a times b times c plus 10b. Can I simplify that? So our task here is, can I see anything that's common to each of the terms in the numerator? You can certainly see 5's common, isn't it? 5 and a 5 times 3 there and a 5 there. You also mentioned a b, someone? There's a b there, there's a b there, and there's a b there. So it looks like 5b is common to each of the terms. So I'm going to write that out the front. 5b. Now, what have I got to multiply 5b to get 5 times a times b? And the answer is a. What have I got to multiply 5b by to get 15 times b times c? 3c. Looks good. Yep. And lastly, what have I got to multiply 5b by to get 5b? That should be a plus there. That should be plus 1. Because 5b times 1 gives me 5b. So all I've done here is I've used my distributive law in reverse. In fact, have I got my distributive law sitting here somewhere? Probably on this one, is it? No. Because I said it was important. And somewhere along the line, of course, I can't find it. Nope, obviously using the sheet somewhere. Here it is. This is what essentially we're going this way. We're saying a times b plus a times c, taking the a out the front and left with the b plus c. We're just going this way this time. Okay, let's look at the denominator. What can I see that's common to both of these? Certainly 5 is common to the 25 and the 10. There's a b there and there's a b there. So it looks like there's a 5b also common there. Now I'm going to have to multiply by 5ac. So that will give me 25abc plus 2. Having managed that, I can now say, I mean, you probably don't have to write this step in, but I'll write it in anyway. A plus 3c plus 1 on 5ac plus 2. And of course that number there is just 1. And so this becomes a plus 3c plus 1 on 5ac plus 2. So here I've cancelled out the 5b's. And so I'm able to rewrite that expression as that. And so lastly, let's do D. D says 7 times m plus n times m minus n all over 4 lots of m plus n all squared. Now, on looking at that, it looks really tempting. Look, I've got a difference of 2 squares here, and I've got a square of a binomial here. So it looks really tempting to multiply or to simplify the numerator and to simplify the denominator. But in this case, that doesn't turn out to be a clever thing to do. What is clever is this, to say this is actually m plus n times 7m minus n. And on the bottom I've got here m plus n times 4 lots of m plus n. So all I've done is rewrite the multiplication in a different order. Here that's m plus n times m plus n, that's m plus n all squared. And you can see now I have m plus n as a common term to the numerator and the denominator. So I can cancel those out. So I could write that as m plus n on m plus n times 7 minus n over 4m plus n. And so I just end up with So in that case, I cancelled out the m plus n terms. Yeah?
Why or how? I didn't quite get how you could go from that to that.
That from that line to that line?
Yeah.
Yep. Think back to numbers. If I've got 3 times 2, that's the same as 2 times 3, agreed?
Yeah.
Yep. So in here, if I've got that number times that number, well, I can just swap the order around. So all I've done is just rearrange the order in which I've done the multiplications.
Yeah, but the low one though, how'd you do that?
Sure. That's, here I've got 4 times m plus n times m plus n. That's m plus n all squared. All I've done is bring that one around to the front. Okay? It's a matter of practice for seeing which way you can rearrange things. Okay? And practice is really the only way you get good at it. The more you see, the more you'll get an idea of what to do. Yeah. Okay? So, someone that's done this a lot could do those mentally and say, oh, yeah, no, that's not a good one, I'll do it this way. When you're still beginning, you have a tendency to just get frustrated and say, I don't know what to do. But what I would say is just try different ways and see how it goes. Okay? Yep.